Today in this video, I will be solving one problem. Here the problem has been noted down. Determine the fixed in forces for a given beam. Here the beam is axially rigid. So what we need to calculate here? Fixed in forces. That is FMB, FSB and FME and FSE. Here I have named near end as B and far end as E. Anyway, let's start how we will be solving the fixed in forces. Hope you have studied this equation in the second year, that G2 Uy by dx square is equal to m over Ei, where m is what? Bending moment, and E and I you all know very well, and where Uy is what? Deflection of the beam. So we will be using this equation only for solving this problem. Okay, so let's consider a section at x distance from B, between B and C. Between B and C, I will consider a section. Between B and C, you will see in the figure. Between B and C, I am taking a section at x distance from end B. Okay, so FMB will be acting na, and FSB. So if we will take moment about this point, so what we can write moment is equal to? Moment is equal to FSB minus of FMB. I have taken anti-clockwise moment as positive. So when you will do na, so you will get this m is equal to SFBX minus FMB. And we will substitute this value of m in the equation first. Whatever I have discussed here, we will substitute the value of m in this equation only. So what we will have after substituting, we will have d2 Uy by dx square is equal to 1 over Ei. In place of m, we are substituting this FSBX minus FMB. On performing integration, so when we will perform integration, what will happen? So we will have du y by dx. That is nothing but slope only. We can write theta is equal to du y by dx. So what will have 1 over Ei. Just we can integrate. So 1 over Ei is constant only. So FSB x square by 2 minus FMB x, and one constant term will come. I have named as C1, integration constant. So theta is equal to this. So I have named as equation 2, and again after performing integration of equation 2, what will have? So we will have Uy. So 1 over Ei, again it is constant. So FSB x cube by 6 minus of MMB x square by 2 C1x plus C2. Again integration constant will come. So I have name as C2 integration constant. So now applying boundary condition. So applying boundary condition is what? At x is equal to 0, it is fixed support. So it is fixed at x is equal to 0. At x is equal to 0. At x is equal to 0. So theta will be 0. It is fixed support. And as well Uy will be also 0. So we will apply. So putting in equation 1 at theta is putting in equation 2, we obtain what? So x is equal to 0 in this equation. So theta is at x is equal to 0, theta is equal to 0. Now we will substitute this whole thing. So now we will have C1, the value of C1 we will get 0. Okay, and again at x is equal to 0, our displacement is also Uy is also 0. So again when we will put this x is equal to 0 in this equation, when you will put C2, you will also get 0. That's why I have written here C2 is also 0. Okay, and now again I will consider a section. Initially I had considered section between B and C. Now I will consider a section at x distance from in B, but between what? Between C and D. Between C and D. Between B and D. Okay, so at x distance from end B. Okay, so when we will be writing into one concentrated force is acting in this case. So when we will write moment equation na, about this point. So m is equal to fmb and fsb into x na, concentrated force into what, lever arm x, and if this concentrated force is acting, minus of 15x minus 2. I have taken anti-clockwise moment as positive, and you will do, now you will get something like this only. Okay, so again we will substitute this m value in the equation 1 only. In equation 1 only, d2y by m I will substitute, new m whatever we have now we will substitute that. So on substituting we will have d2uy dx square. So d2uy by dx square is equal to 1 by ei into f sbx. We are substituting the value of this m, minus fmb minus f15x minus 2. Again I will perform integration, so we will get slope na. The slope is equal to duy over dx is equal to slope only 1 by ei. The fsb x square by 2 minus fmb x minus 15x minus 2 whole square by 2, and one integration constant will come. So I have named as C3. I have written here, where C3 is integration constant. I have written also. And again performing integration to this equation, so we will have uy is equal to 1 over ei fsb x cube by 6 fs x cube by 6 and what, minus fmb x square by 2 and minus 5x minus 2 cube by 2 and plus c3x na. And again one integration constant will come, that is c4. Again I have written here where c4 is integration constant only. Okay, and now again considering a section at x distance from end b na, at x from end b. See here what I will do now. Again one concentrated load is acting na, you can see in the diagram also. One concentrated load again it is acting na, of 10 kilonewton. So see, again we will take moment about this point. So what will be the moment equation? So m is equal to fsb minus of fmb and minus of 15 x minus 2. From here to here it is what, x na, so we will subtract 2 so that we can get exact lever arm, and x minus 5. From here to here it is x, and if we will subtract total 3 plus 2 plus 3, that is 5, then we will have exact lever arm. So again I will put this m value in the equation first only. Now initially I have shown na, so d2uy by dx square is equal to 1 over ei fsb x minus fmb and minus 15x minus 2 minus 10 of x minus 5. Again I will perform integration. We will be getting slope is equal to du by dx 1 is equal to 1 by ei fsb x square by 2 minus fmb x minus 15x is minus 2 whole square by 2 minus 10 x minus 5 whole square by 2 plus c5, where c5 is what, integration constant. And again on integrating we obtain what, uy is equal to 1 over ei fsb x cube by 6 minus fmb x square by 2 minus 5 x minus 2 over q by 2 minus of 5 x minus 5 whole cube by 3 plus c5 into x na. Again some integration constant will come, c6. I will name as c6. Now I will be applying boundary condition here at x equal to 10 also. Here at x equal to 10 also there is fixed support. So obviously at that position also theta is equal to 0 and uy will be 0 only. When I will put x is equal to 10 na, so theta will be 0 na, in this equation I am going to put. Okay, when you will put x is equal to 10, see here what we are getting. So we will be having this equation in terms of c5. I have find out the equation. Okay, and at x equal to 10 also uy will be also 0. Okay, that's why I have written is equal to uy is equal to 0 over 1 na, put, and I will get something equation like this. So I have named equation star and equation double star. Okay, We are getting these two equation na, when we are putting boundary condition at x equal to 10. Now we need to apply some more boundary, we need more equations so that we can solve this all equation. So we will apply additional conditional equation. What additional conditional equation we have? At x equal to 2, at x equal to 2, theta and uy are respectively same from both sides. From both sides it should be same na, at x equal to 2. Nah. Nah. Okay. At x equal to 2, theta and uy should be same na. So what we are doing, just we are putting x equal to 2 in which equation? Hope you can understood these all things na. And it means initial when we have considered between what b and c na, 1 over ei fsb 2 minus fmb2 plus of 0 and is equal to 1 over ei and fsb2 minus fmb2 plus c3. You can see I am putting here theta is equal to theta should be same na. See here. Now in this equation I am putting x equal to 2, and in which equation I am putting this, in this equation x equal to 2 I am putting, okay, and between what, between c and d na. So between c and d, this so in this equation I am putting x equal to 2. So that's why we are getting okay, c3 here it is na. Hope you are understanding these all things, okay. This is not very big concept, okay. So c3 from when we have equated this, so we are getting c3 equal to 0. Similarly we will be equating for uy also, okay. At x is equal to 2 and from both sides it should be same, okay. So we have equated and c4 we are getting as equal to 0 only. So again at x equal to 5, again at x equal to 5, theta and y uy are respectively same from both sides, okay. It means where I am putting x equal to 5, I am making you understand at x equal to 5, okay. In this equation also we will I will substitute x equal to 5. So theta is in this equation, no, sorry, in this equation, okay, c5 we will be getting, and in this case and in this case, okay, and in this case I will be putting, okay. See, finally we are having this, okay. c3 where there we have 0 na. So c5 equal to 0, okay. Again uy should also same from both sides. So c6 also when you will be doing by your side na, so c6 will be also 0, okay. Just I have okay. Now solving equation star and double star for the calculation of FMB and SB. Where is equation star and this is na? So this is c5 equal to 0 we got, and what c6 is equal to 0 we also got, and c5 also we got. So we have two equation in terms of FSB and FMB. Now we have two equation and two variable only in terms of FSB and FMB. Now we can solve nicely. We can solve. I have done all the calculation for you for your better understanding. Okay. So here I have written. I have calculated. So I have got FSB is equal to 18.44 kilonewton. When you all know how to solve this two equation, two variable equation. Okay. Now now we got FMB and FSB, FMB and SFB, FMB and SFB we got. Okay. So now what I am doing, applying considering upward as positive, sigma f of y is equal to 0. Overall it should be 0 na. So FSB plus FSE minus 25, how I have written, I am making you understanding, I am making you understand how I have done. So FSB is acting upward, and this 15 is acting downward, and this 10 is acting downward, and this FSE is acting upward. In this way I have written FSB plus of FSE minus 25 is equal to 0. So FSB we know, FSE we got 6.57. So in this way we can calculate FME also, okay. you don't need to worry about that. How I have written here. So thus required fixed in process will be what? FSB, FMB, FSC, and FMB. This is the way of writing the fixed in process. Here the beam I have considered the axially rigid. So no. So finally we got this answer. I have done all the calculation for you. If anyway, if you have any doubt in understanding this all concept, okay, this all calculation, you can write comment in the comment section.